Okay, checkpoint 2. This one is on page 990, I believe. Yes, it is. And the question says, find the 7th term of the geometric sequence whose first term is 5 and whose common ratio is -3. So now, obviously, there's a couple of ways to do this. If the first term is 5 and the common ratio is -3, then we could realistically just multiply by -3 all we wanted until we got to the 7th term. That's totally a viable way to do it. But instead, I'm going to use the general term formula that we did in the notes. And the general term formula looks like this. AN, so the nth term of a geometric sequence, is A1. So I wrote that wrong. The first term is 5. Let me make sure I have this written. I don't know why I blundered on that. A1 is 5. Make sure I have that right. And the formula for the nth term is A1R to the n minus 1. Remember, n minus 1 is in our exponent here. That's because every single time I'm multiplying by r, so my exponent just grows by 1 power every single time. So I'm looking for the 7th term. And that is going to be A1, which is 5, times r, which is -3, and then 7 minus 1. So remember, in order to solve this appropriately, you need to do the exponent first, then your multiplication at the end. So you would get 5 times, it'd be -3 to the 6th power. So 3 times 3, 9, 27, 81. Let me use a calculator here so I'm not trying to do this in my head. You do 3 to the 6th. 3 times 3 times 3, third, that's the 4th, to the 5th, to the 6th. That's 729. Remember, it's an even number of times, so you're going to end up with a positive number. So 5 times 729. And that means our term is 3,645. And remember, if you wanted to do every term, you just start with 5, multiply by -3, then multiply by -3, then multiply by -3 until you get to the 7th term. Negative, multiply by negative, multiply by negative, multiply by negative, and you get 3,645. Yep, just wanted to double check. I knew that was right. So that's checkpoint 2.